G'day, welcome to another video. I think last video I was talking a little bit about what was I talking about? These PDP plots. On Friday, just before I left my office, I left at lunchtime because I had a conference in Tokyo on the weekend. I left at lunchtime. I set the models that I was constructing using the entirety of the data. I set those to construct at Friday lunchtime. These were constructed for regression analysis, not categorization. So I was using the Likert scale averages that are in the Glasgow norms data set. The models took longer than expected to construct. They took well, they didn't finish, right? I started at Friday lunchtime. I came into my office Monday morning, and it had constructed the first 3 models only. In addition to that, if you can see up here in my environment tab, we have 2.32 gigabytes worth of data up there, the most of which of that must be the models that were being constructed. And what's happened, because those models aren't saved, they're kind of sitting in my environment here, they have turned my computer into a bit of a brick. So I need to figure out what to do about this. That, in addition to the fact that the plots, the PDP plots, the results are kind of questionable. I'll explain what I mean. They look great, like they're really clear in every single case. They're really clear. They show either a positive or a negative correlation. However, it's just there's a questionable. Let me find the spreadsheet that I need to show this to you. All right, so we've done the first 3, right? For arousal, the L sound had a high distribution to so that highly arousing, and then all these other sounds had a, according to those plots, were low. The directionality was to the low category, right? Now, a lot of sound symbolic relationships across linguistic, and I personally believe that there is there is something in our evolutionary history that connects with sound symbolism, right? I personally believe, I'm still working on the evidence for it, but I think that it's highly likely that sound symbolism had a big part to play in our the evolution of human speech. So it might make sense, this directionality for most of these sounds. It might make sense for this to be low, because if you think about it, the opposite of arousal is disgust, and being able to express disgust would be incredibly evolutionary beneficial, right? Don't eat that, it's bad, right? Or don't touch that, it's fecal matter, something like this, right? So being able to express disgust, evolutionary speaking, would be incredibly helpful. And that might account for why all these sounds are expressing like low disgust, why the most important features in this model are expressing disgust. And so I thought, well, that's kind of interesting. There might be something to it. Then I looked at valence, and I started to think, well, this doesn't really seem right. So for valence, we see something really similar. We get a high feature importance for R and high for P, but low for every other important sound. And I got to dominance, and R was high for dominance as well. And I was just looking through those plots, and I lost patience with it, because I think there's something wrong with them. They were all showing a low directionality. So directionality to the non-dominant group. Let me show you what I mean. So I've got R. Let's do S, L, T, and K. We're looking for dominance. R should be a positive correlation. Negative, sorry, negative. positive. Let me just go back and check. Sorry. R should be high. Well, that's obviously low. S. So that's low. LTK. Low. And K. Okay. So what we're seeing is, almost all of these features, it's suggesting that not almost all of these features are contributing to a classification to the zero the zero category, which is a red flag for me. I've got an idea for testing directionality. It's an idea that I had a while ago, and I think I'm going to try it. I'm also going to try something. There's a Shapely package. If you're not familiar with Shapely, what it does is it kind of looks at the way that they might interact. I was at a conference in Paris last year, and there were a couple of researchers looking at diphone sound symbolism, specifically diphones that occur at the start of the word. So like gleam or glint or glisten, these all seem to have a relationship with sparkly or shiny stuff. So yeah, Shapely equations might be helpful here, but I have a bit of a homebrew way of testing directionality, which I've never actually put into practice. Right now, it's just theory. And what it is you take the existing model and the existing test subset, and you essentially reduce the value of the phoneme that you're interested in examining in the testing subset, and then feed it back into the model and see if classification accuracy goes up or down, or see how it's reclassifying those samples. Not whether it goes up or down, see how it reclassifies those samples. So you'd look at, let's say that you have a sample and, let's say you have 100 samples, and there's a kind of like a 50-50 split as to how the model is classifying them. That's not the accuracy, that's how the model's classifying them. And then you reduce the value of one of the features, right? Let's say it's the vowel. Uh, that's transcribed in alphabet as AH, or it's the but vowel, the upside down V. So let's say we're dealing with that. You reduce the value for that and then see which way the model starts trying to classify those samples. And on the other end of the spectrum, you could add a value to that phoneme and then see which way it's going to try and start classifying to those samples. And that's going to give you I would think, a pretty clear view of directionality. So in the next video, I suppose you'll find out which one worked. Either it's Shapely or it's my homebrew test. But I don't have any faith in these PDP plots. So yeah, the adventure continues, I suppose. All right, that's it for today. I'll catch you in the next video.